This week, first up, we learn how to work with OpenVAS, the open source vulnerability scanner. Then we welcome Patrick Wardle, founder of Objective-C, to talk about trends in Mac malware and Apple security. In the security news, some describe T-Mobile security as not good. If kids steal Bitcoin, we'll just sue the parents. Newsflash, unpatched vulnerabilities are exploited. Insiders planting malware, LEDs that can spy on you, hacking infusion pumps, Prism variants, because everyone knows I love variants, 1Password vulnerabilities, and plugging a mouse in gives you admin. All that and more on this episode of Paul's Security Weekly.
This is Security Weekly, for security professionals, by security professionals. Broadcasting live from G-Unit Studios in Rhode Island, it's the show where exploits run wild, packets aren't the only things getting sniffed, and the cocktails flow steady. It's Paul's Security Weekly.
Every 11 seconds, there's a new ransomware attack. Oil pipelines, universities, corporations, all paying millions of dollars. Barracuda says, don't pay the ransom. Before a ransomware attack occurs, train your teams to recognize an attack and use anti-phishing technology. Protect your applications, and they can't get onto your network. Simple backup and restore solutions quickly recover your data without paying the ransom. Build your ransomware protection plan now by visiting securityweekly.com/Barracuda. That's securityweekly.com/Barracuda.
And welcome to the show. Got it this week. Hey, first, let me introduce you to a man who's ready for his close-up, Mr. Paul Asadorian.
Welcome everyone to Paul's Security Weekly. It's episode number 708. My lunch recorded on August 26, 2021, right here in G-Unit Studios in Rhode Island. The illustrious and beautiful Mr. Larry Pesce is to my left.
Hell yeah. And I didn't screw up that intro this week.
We're good.
Yeah, did it. Hooray.
Hooray.
I remembered.
On the lines remotely, Mr. Tyler Robinson, back from some stuff. He's back though. Glad to have you back, Tyler.
Back, and I'm not dead. It's a good day to be alive.
You fought all the ninjas in one.
All the ninjas. Mm-hmm. Yes.
Do you know what kind of shoes
they
ninjas
were
wear?
wearing white.
What kind, Larry?
Sneakers.
White ones. Shit.
Mr. Jeff Mann is here with us remotely this evening. Jeff, welcome.
All I heard was sneakers. So score one for sneakers.
Sneakers, the ones you wear, not the movie. I'll give you half a point. Mr. Lee Neely is here with us. Lee, welcome back from a little kind of
good
vacation.
To be here. No sneakers in this house. Not no sneakers here.
Sandals.
We're barefoot.
There you go. Well, you were just in like Hawaii or something, right? Do they wear shoes?
Yeah, I was in Hawaii last week, and then just for fun, we did a run up to meet with a friend up at Coeur d'Alene for a meeting last night, and about 375 miles each way. It's not a bad little trip.
Nice. Security Weekly Unlocked.
Maui was more fun.
Sorry, Lee. Security Weekly Unlocked will be held in person this December 5th through the 7th at the Hilton Lake Buena Vista. We're excited to announce our first round of speakers that includes Leslie Carhart, David Kennedy, Alyssa Miller, O'Shea Bowens, Marina Chiavata, Patrick Coble, Chris Eng, Eric Escobar, Nick Leghorn, Michael Schlatt, Kevin Johnson, and Justin Kohler. Visit securityweekly.com/unlocked, register, and check out the Rockstar lineup. And now we're going to talk about OpenVAS. Yay! Just a little bit of a background. Adrian and I are nearing completion of our product labs testing on vulnerability management. I designed into the program that when we do products labs testing, that Adrian would largely handle the commercial products and I would handle the open source products because I love Linux and open source. I mean, Adrian does too. But I was like, this is really fun. So I get to test all kinds of cool open source stuff. And one of the things I tested was OpenVAS, which is really interesting. So I guess because I worked for Tenable for so long, so I gained deep insights into the Nessus vulnerability scanner. And, well, there's a history there. I'll briefly go over the history for those that may not know or maybe remember all of the details, right? But first I want to start with what problem are you trying to solve? And so when you're looking at open source vulnerability scanner, maybe you need a vulnerability scanner, but you're short on budget, but flush with time. That is when I believe you should look at open source solutions to solve your problems.
That is an amazing way to put that.
Right? You want to build a vulnerability scanner into your environment and not pay license fees from a commercial company. Maybe you want to run regular scans. Maybe it's product specific, environment specific, and you don't want to license commercial products for that. You also may desire ultimate control and flexibility. As we'll see in this segment, compiling things from source, you also get an understanding of how it works in order to troubleshoot more easily.
And ultimate flexibility.
And ultimate, I mean, if you want to dig in and change the code, I mean, you can do that.
Flexibility may also be read as frustration, right?
Could be.
Ultimate frustration.
Yes. You also may need to set up a vulnerability scanner to make a point at your job that maybe the points could be you have vulnerable systems. A vulnerability scanner could help identify said vulnerable systems, and maybe your patch management program is inaccurate or teams are overconfident, and a vulnerability scanner can help you with some of those things. A little bit of the history. In 2005, Tenable decided that Nessus version 3 would be closed sourced, leaving Nessus version 2 remaining under the GPL and fully open source. I joined Tenable, just as an FYI, in March of 2009, where it was still fresh on people's minds that Nessus version 3 was closed source and Nessus version 2 was still open.
4 years later.
4 years later.
The industry was not bitter.
No. No, they were. And they told me about it, which was fine. That was part of my job at Tenable. I embraced it. Several forks appeared shortly thereafter in 2005. Obviously, most notably was the OpenVAS project, Open Vulnerability Assessment System. Greenbow Networks, which is a German-based company, spearheaded the effort to continue developing OpenVAS. So I didn't look to see like how much of the OpenVAS source code was still the code engine that was open sourced. I did see in some of the updating that some of the like nasal scripting stuff that was open source at the time in 2005 was still there. They're likely maintaining some of that. What happened is the commercial versions of Nessus and the open source versions of Nessus took two very divergent paths from an architecture.
They forked, if you will.
They forked, yes. But architecturally, they became very, very, very different.
Oh, sure.
Yeah. So the Greenbone Security Manager appeared in 2010, furthering Greenbone's efforts to turn an open source vulnerability scanner into a full-fledged vulnerability management platform. So that is their commercial play today. Now, OpenVAS, like when you use just the term OpenVAS, that it describes many different components. I was actually kind of astonished that I was like, oh, I download the scanner like I downloaded Nessus and I go run it. And no, there's a lot of different components, some of which are on this slide. And I plucked these from GitHub just to show people that there are, I think, 7 different components that you have to download and compile if you're going that route, or put together if you're doing a VM or a container.
Ultimate flexibility.
Ultimate flexibility. The GVM, so Greenbone Vulnerability Management Solution, has its own set of libraries. These libraries are used by the other components and form a standard library that they used for in their architecture process. I couldn't easily find like a really good architecture diagram. If someone at Greenbone happens to catch this, like I'd love to catch up. I'd love to kind of see more of a kind of functional design architecture diagram of how all these components fit together. I can kind of guess based on some of these descriptions and having it set up. So the second thing is OpenVAS itself. So this is the scanner. This is likely what still probably shares some of that code with Nessus version 2. Then there's the OpenVAS SMB, which is a completely separate GitHub repo that handles the SMB components, likely because there's so much going on in SMB that decided to put that in its own repo.
Kind of makes sense.
Yeah. Then there is OSPD.
Oh, Christ, there's more?
Oh, there's more. This is 4 more. This is a total of 7, right? So this is the Open Scanner Protocol. According to the documentation, creates a unified interface for different security scanners, making their control flow and scan results consistently available under the Greenbone Vulnerability Manager service. So there's actually 2 different kind of middleware layers, right? Because the Greenbone Security Assistant is the web front end. The Greenbone Vulnerability Manager is yet another middleware kind of system. As well as you also need the OSPD OpenVAS, which is the OSP server implementation, allowing GVM to remotely control OpenVAS. So you have like the scanner, kind of these multiple middle layers that do this queuing for the scanners and things of that nature, and also do the communication between what the user is telling it to do in the GUI. There's a reader server involved as well, and all these components kind of fit together to make up more of a vulnerability kind of management. It also alludes to the fact that you could, the open scanner protocol, you could attach another scanner to if you so chose. So they've kind of like extrapolated out these parts of like scan, scheduling and management, communication of the control plane, like, hey, I want to run a scan against this network kind of thing, along with the actual scanning component and then the reporting of the results. So they've kind of pulled all those pieces apart, and that's why you have 7 different projects that have to fit together.
So my question to you, you called them out on, hey, we need a functional diagram of what this looks like. Yeah. I can see functional diagram needed here for because my mind is already struggling with it.
Yeah, that's what I couldn't find in their documentation, is kind of how all these pieces fit together and exactly which data they share over which protocols. I think it'd be super, super helpful.
Yeah,
and I could go like reverse engineer and try and figure it out, but
and that was they're all on GitHub, so they're open source projects, so they could conceivably accept pull requests from somebody in the community that understands how this works to create said documentation.
Right. Correct.
But I think you kind of hit it right on the head that, hey, Greenbone, please.
Yeah, and maybe I just couldn't find it, or I mean, I did poke around on their website. In any case, it would be helpful. So to get OpenVAS or the Greenbone Vulnerability Management Platform, which is what you ultimately end up running, as I did not see like a clear way to just use like the OpenVAS scanner from the command line kind of thing. So there's 3 different ways to get all of the components, right? One, you can download a pre-configured VM from Greenbone, which requires registration, which that's nice if you want to go down that route. I wanted a little more challenge and a little more control, and maybe you don't want to give them your registration information. Maybe you do, but that's out there, and they do provide that for you. There are several open source projects that have made available Docker container builds. Some are very out of date. Some are up to date. Not all of them work very well in my testing. I did find one. The link is in this slide deck, which is also linked in the show notes for this episode. So if you go to securityweekly.com/PSW 708, I believe is the page for show notes for this. There's a link. This is a PDF version that I'm giving out for free for anyone who wants to take a look at it and see the notes and all the links. So IMMAUSS, iMouse. There's a gentleman that runs this company, cybersecurity company, and has graciously provided an awesome container system for running this. So I'm going to go through all the components and how to compile it from source, but realize you can go to the iMouse GitHub page that I linked to in this, and in 2 commands. One command, you create a Docker volume. I believe I might be getting that confused with my Nmap container, but basically in a couple of commands in Docker, you can spin up OpenVAS. In fact, in production, like that's how I run it. I actually just use the container builds because I find it to be a little cleaner and neater and much easier to maintain, as this guy does the maintenance for it, right? Right. So then you can compile all of the components from source. This is tedious and time consuming, but a great learning experience, because if you're going to run this in a VM from Greenbone or in a container system, my feeling is you should know a little bit about how it works under the covers in case something breaks. You'll have a much easier time troubleshooting it. There was another individual that I want to call out, Macyotox, MAKYOTOX.
Macyotox? I'm guessing.
Thank you, Larry. .medium.com is his blog.
I knew you were going to have a problem with that, so I practiced.
Thank you. Thank you.
I don't even know if that's right, but
he has a guide on installing OpenVAS and Greenbone on Ubuntu 2004, and that guide saved me a whole ton of time. Because if without that guide, you'd have to go read all the individual instructions for all of the GitHub repos and read some of the forum postings on Greenbone's site. So like he did that all for you. And I do have tweaks to his guide. So if you're listening, either people are listening, you guys are awesome. Thank you for your contributions. I've reached out to the iMouse guy on LinkedIn. I gave a shout out, I believe, to the Greenbone guide that was written by that individual on Twitter as well. So I tried to reach out and also thank them for their contributions, because this segment is based on much of their work. As I used some of the container Docker files and such to make sure I had all of the components and packages installed when I was compiling from source. So this guide that shows you how to compile and install it on Ubuntu 20.04, I also had to add some of my own tweaks to it, because since that was posted 3 months ago, the OpenVAS developers made some changes. But I'll walk you all through it. The setup. I really like VirtualBox. Larry, you and I were talking about that at a meeting this morning.
Yep.
I actually use the packages in the Ubuntu repo to install VirtualBox, which I also found works with Detection Lab. And just as an FYI, I rarely find that this works. So anytime I install Docker, Golang, Ruby, Node.js, and try and install an open source project on top of it, I find that I have to go to the official repos and or GitHub repos for those projects and install them a specific version that works with the open source project that I'm working with, because rarely what's included in Ubuntu is the right version for what you need. However, in this case, the VirtualBox that is packaged with Ubuntu 20.04 works great, which is what I'm using for the VM build as well. I used Ubuntu Server 20.04. I followed the instructions in the link in my presentation to install VirtualBox tools. I'll leave that as an exercise to the reader. I gave it 2 cores, 30 gigs of disk, and 16 gigs of RAM. Now, you could probably get away with less, but more is actually more in this case. And just as an FYI, 10 gigabytes of space is not enough, because Ubuntu Server takes up about 7 or 8 gigs in that.
Ask you how you know this?
Because I did it and it failed and I had to rebuild it. That's when I went with 30 gigs just to be safe.
And also on that Windows XP VM that you just need for that one thing to do for your ham radio stuff, because of it's an old radio and it still works just great. Don't pre-allocate 60 to 80 gigs worth of disk first.
Yeah, probably not a good idea.
Yeah, no. Ask me how I know this.
So that's the setup.
I'm surprised 2 cores is enough. I would have expected not memory, but cores to be a challenge.
Yeah. And again, your mileage is going to vary. It's going to depend on how many systems you're scanning and how fast you want your scans to take, right? I mean, in my testing, the more resources you throw at it, the faster the scans run, basically, rightly. So the next step. So now we're getting into the actual compilation steps. This is a pretty long and tedious process, not going to lie. Had to do it a couple times before I got it right, and then do it again to compress it down a little bit and make it more repeatable. So the first thing you do is install prerequisites. Now, these are like all of the prerequisites. And I got it to a point where I could install all of these packages, and then throughout the rest of the process, I didn't have to apt-get install anything else. So I did it a couple of times and then went oh, I forgot this package, or I need this package. So this is the complete list that I was working with to install all of the prerequisites. First thing you need to do is, as I was saying earlier, install the official package repo for Yarn, so that when you apt-get install Yarn, it installs it from the official repos, which gives you a more recent version than what is included in Ubuntu 20.04. So that's those steps. Then you need to add a GVM user and install the database. The GVM user is what will allow you to run all these processes. It's also the same username that will be installed in the database. And the setup will basically take into account that you've created a GVM user to do all of your management of OpenVAS. Very standard, Linux commands, Unix commands to add a user. I did then set a password for this user and add them into the sudoers file, giving them full permissions. And the reason I had to do that is because changes that were made a few months ago in the OpenVAS repo, I'll explain a little later on, but essentially what they did was they said if you specify the prefix as /opt/GVM, they don't honor that for all installation locations, which means it will install stuff in places that require root access. And the OpenVAS developers have said that this is more standard, and we don't want to deviate for some of these file and directory locations, but that also changes how you build and install, because you have to do sudo make install rather than make install, and then change some permissions so your GVM user has access to those.
Jeez.
Yeah. So that was the bit that changed recently.
On this one, I noticed it's sort of the top there with the creation of the users that the GVM and OpenVAS packages is a comment. So the line is preceded by an Octothorpe.
I missed a pound sign there. I did. It resized. Yes.
Oh, no, not so that it resized, but the other commands are also comments?
No. Good point, Larry.
Because they are prefaced by an Octothorpe.
I should have had a slide that explained my format, which is I made a mistake in my format. Comments should be in green and preceded by a pound sign. In this case, I missed one of the pound signs, but the comments are in green. The commands that you type are all in bold.
Okay.
Commands that are run as root have a pound sign in front of them, and commands that are run as a regular user have a dollar sign in front of them. That was my format.
Your slide needs some work.
What's that?
Your slide needs some work.
Yeah, in here I apologize. I missed a pound sign in front of one of the comments.
Yeah, I get that it wrapped, but because I was
that was a Sans thing too.
Yeah,
I think Sans first told me that like commands need to be in bold. If it's run by root, it's pound sign. Regular use is a dollar sign.
Yep.
And I put comments in a different color.
Yep. Because your sudo command is not being run by root. Because if you are root, you don't need sudo.
I'm using sudo to
use the Postgres
get to
user.
the Postgres user.
Got
That's
it.
correct.
That should have been a dollar sign there, buddy.
No, because he was root already. And
I
he's
am
using
root, and I want to be Postgres.
Yep.
So the instructions use sudo.
See?
You could have
minus
used,
user, Postgres.
You probably could have used SU. The point is you need to become the Postgres user using either SU or sudo.
Yep. See? I told you I was going to heckle.
That's good. That's good.
But we're good. Nice.
Next thing you need to do is clone the repos. So you become
Comments in green.
Comments in green.
Prefaced by the Octothorpe.
Yes. Prefaced by the hashtag. It's not a hashtag in this context. It is not a hashtag. It's a pound sign. So I become the GVM user, and then I execute all these commands. I update my package config, which gives me the extra library path for when I'm compiling it. So anytime you become the GVM user, you'll notice you have to export the package config path variable to set up the path correctly for compiling and building stuff. Also of note on this one, 20.08 is the latest stable version of OpenVAS. There is a 21.08 or the next version that's still in active development, and I've tried to compile and use that version, and it is a no-go.
You just noped right the hell out of that one.
No-go. No, that is a no-go. You can try if you want. If you want even more pain and suffering in your life, you can try. But it realized it's under active development, so I stuck with 20.08.
The alpha or the development branch, as it were.
Yes, correct. Now you need to build some of that source to get you started. So you make a build directory. You run the cmake command. So like cmake makes your make files and configure scripts, right? Because so it's like a build process to build your build process. In fact, and then sudo make install, because like I said, they took it upon themselves to make changes that force you to become root when you do make install, and then also change permissions of files after the fact, which I did all that and got it working. You'll need to also go build. So you need to, in this step, you're building the GVM libs, the OpenVAS SMB, and OpenVAS. And then you do all that. And then
you do all this.
You go back to root. You do all this. LD config updates your library path and headers, because you installed a bunch of libraries. So when you come back in your root, you need to make sure you update that. And I even put some links to some of the things that are happening in these commands. I have some reference links in there in case I either don't cover them or didn't remember what some of the commands did. I did research all of the commands that you're running and put references there at the bottom of the slide as well. So you have to configure is it Redis or Redis? I don't know the correct pronunciation. I think I've heard it both ways.
Yeah,
Redis.
I say Redis.
Redis, okay. So you have to install Redis, do some stuff for that. You have to, the links that I provided at the bottom of this slide explain why you have to increase your core SO max connection variable setting in syscontrol.conf, as well as changing your values for overcommitment of memory as well. Yes.
Sounds complicated.
It's for Redis, and the full description of why you do that is in those links at the bottom. So you update your syscontrol config. You then disable transparent huge pages, which is also explained in my links below. That is an important step. Again, something about too many files open at once or something is the error that you get, I believe, with Redis, or one of the other components, I forget which, but something, if you don't do that step and disable transparent huge pages in the kernel, you will get errors to the effect of too many open files. And ulimit, according to these links, will not fix that problem for you.
This sounds fantastic.
Yes. So you do your system control things, reload the daemons. You give GVMs what it should have in the sudoers file. So I'll go back and I'll remove my entry from the sudoers file that gives you all access as root, and I'll go with what was presented here. So this gives the GVM user the access that it needs in the sudoers file. And so I'll remove the password and the whole thing after the fact, after I build and configure it, because that's the only reason I needed full access in sudo. Then you need to change some permissions on all that stuff we installed in the previous step. I need to make sure the GVM user owns all of those other places that the installs put them, as I explained before. Then you need to update, do the Greenbone NVT sync, which downloads all the plugins. That command takes a really long time. I thought I put a comment in there that command takes a really long time, but that command takes a really long time. Greenbone-NVT-sync. Go get some coffee.
Hey, Dad, are we there yet?
Yeah, go get some coffee. Come back and then build and install the Greenbone Vulnerability Manager and the Greenbone Security Assistant in the same manner that you installed the other packages. Then I think you have to run that chown command again, because those builds put files in other places as well, which I think I did have that in here.
Yeah.
Then you need to update the SCAP data. I think that also takes some time. That first one right there, and the other one's not so much. So there's a couple of commands in there that take a really long time.
And those two are for plugin type stuff?
Yeah. So the NVT one on the previous slide downloads all of your NASL and NVT plugins is what they call the plugins in OpenVAS.
Yep.
And then they also sync your SCAP and CERT data. I think those are the NVD database and your SCAP databases. Those are just databases of bunches of CVEs and stuff like that.
I can see why that could take some time.
Yeah. The certs updates its SSL certificates. I believe that's for getting all of your plugins and updates. It uses SSL as part of the validation to make sure that no one's putting a malicious plugin in or something like that. So it has its own SSL things, which you can see in here as well. Then you have to install OSPD and OSPD OpenVAS, which are Python packages. So there's some Python scripts that run as part of this to run some of these services. Once you install those, then you need to put things in different locations and change permissions so that it will actually run. Because what happened is when the developers made that change, it puts the certificates, for example, in varlib GVM directory structure, which by default does not have the user does not have access to that directory, so you have to move it in or copy it. I probably should move it so the key is in one place, not two, into opt GVM varlib GVM private CA, which is how this build is configured. So you do all those commands to basically fix the thing that the developers decided was a better thing to do. And then you can start the OpenVAS Scanner, the GSA, and the GVM services. So these are all of the middleware vulnerability management services and in the web interface that needs to run in order for you to actually get up and do scans.
And now that your Gen 2 system is installed, now we can install OpenVAS.
Yes, exactly. So there's 3 commands there. First is the OpenVAS Scanner. Next is the GVDM, the Vulnerability Management daemon, and the GSA daemon, which I believe is the Web Interface daemon. Then it gives you a grep command that you should run to make sure all of those services are running. If they're not, I have the log file locations of everything in the last slide as well, if you need to troubleshoot that, which I did. Need to do a lot of troubleshooting to come up with the previous set of commands on this slide that I had to make different directories and move files around.
This is my shocked face.
Yeah, to get it to run, right? Which I didn't have to do when I did this 3 months ago, but now I do. And I'm glad I tested it before this segment. All right, now it's time to create some systemd services. All of the 7 different packages, at least 3, maybe 4 of which are actually running services on the system. For those running services, these are the steps to create them as systemd services and reload them, start them, and enable them. So that's the first round. Then you're going to do some more systemd services. On the next slide, you'll create 1, 2, 3, 4 more systemd services to run all of the various components. Then at part 10,
There is no and then.
There is no and then. And then part 10 is you create your GVM scanner. So you register a OpenVAS scanner. You then create the admin user with a command. So these are, again, the GVM users executing GVMD to create scanners, create users, and make your the feed owner of a particular UID. So this is all just to basically register your scanners and get them created and set a username and password that you'll use to log into the web interface. For troubleshooting, I list the log directories where all of the logs will be that will report the errors in case maybe by the time you get to this, something else has changed and you might need to change your build process. Excuse me. So that's where all of the log files will live. And if it works, finally, you rejoice and you can log in and then start running scans, which is actually pretty easy. And if there's demand, I can show you how to run scans. But it's pretty you go create some targets, create a policy or modify a policy, and initiate a scan. It's a lot. A lot of steps.
I think you need a cigarette.
That might
we
be
finally
worth
have
the-
it up and running. I can pay attention now.
Yes. Now we're up and running with OpenVAS. But again, I think it's important to understand how things work under the hood. If you're just running the scanner and it's not working and you haven't gone through all those steps, you're not going to have any idea, obviously. There's lots of different components, lots of different running services, lots of different configurations.
You were
and
just
commands.
giving me flashbacks of 30 some years ago trying to get stuff to compile on Solaris.
And again, I did this primarily to gain experience I even learned some things about Linux commands, because you're never done learning about, unless you're Hal Pomerantz, he's still not done either, but knows a lot more about Linux and Unix than I do. So I'm always trying to learn. I'm like, well, if I go through this process, I'm probably going to learn something, which I did. And then it breaks, and then I have to fix it, and then I learn more. And now if I run it in a pre-built VM or a Docker container, and something's not working right, I'll at least have some background knowledge to go start doing some troubleshooting.
Yep. Tyler, you got a comment in there?
I was just curious if this makes it worth it to actually pay for the subscription on the paid tools.
In doing these tests, Tyler, I often wonder, and I don't want to point fingers and say anyone's doing this, but I think because sometimes it's very difficult to get the stuff running, do you wonder if they've purposely made it difficult or left things out so that you struggle with it and do exactly what Tyler said and go, I'm just going to go pay for it.
Yeah. And specifically not to Tenable, but to Greenbone.
Yeah.
For their commercial.
Greenbone for their commercial version. Yeah.
And after you get all this going, don't you now have to set up some jobs to run the SCAP data and speed other thing updates whatever interval to keep them current?
That's correct. That's also why I like running it in a container, because I can just destroy the container leave my data volume alone, destroy the container, and rerun it. It's actually also how I run Apache Guacamole, rather than trying to figure out what Tomcat version needs to be. Like, when actually, it's interesting, OpenVAS will find the vulnerabilities in Apache Guacamole and go, hey, Paul, you need to patch those. And by patching them, I just destroy the container and build a new one. And it rereads my config, and the world's a better place.
Holy guacamole.
Holy guacamole, Batman. Yep, it's a great point, Lee. Yeah.
But Lee, he in that configuration, I did see that he had the commands for updating those databases.
Yeah, he did.
So, yeah, but Lee's got a point. You should probably run those on cron.
Yep.
Keep them up to date on a regular basis. Mm-hmm. Yep, good catch, Lee.
I mean, if I'm trying to protect my phony baloney job, I need to do this all by hand.
Well, right.
But who has
Step
time
11
anymore to do this shit by hand? Oh my God, this is cool, but boy.
It also, huge props to the maintainer and maintainers of the container system, because they're basically repeating this process, but automatically in shell scripts and Docker files to build the containers. So that's really cool. Also, I have a webcast that I have built. The slides are built. It's ready to go. We're really just looking, I'll be honest, we're looking for a sponsor to have a sponsored webcast, and I will walk you through how to work with the results, how to do Nmap with vulners, how to do OpenVAS, run some scans, validate some results, use another open source project called vols.io. Have you heard of vols.io? It uses SSH to create trust between systems and do vulnerability management on your Linux systems. So I'll show you how to, that was another adventure in open source as well. So I'll show you how to set up, configure that, and run that. Get their web interface is really interesting. There's a lot of stuff in the vols.io. They'll let you filter on vulnerabilities and sort them. Really complex web interface for that. So we've got a webcast all put together. Check the Security Weekly website and or our mailing list to learn about when that is scheduled. So I do have that, and we're looking for a sponsor for it. So cool. Next technical segment will be, I will be sharing my Nmap and vulners configurations. So a little bit about FlanScan from Cloudflare, but also how to pin up your own Nmap container. So I did a build for an Nmap container that I'm really happy with. I'm going to share it with the audience. And interesting things about the results that you get. Not so thrilled with vulners. I'm actually pretty impressed with the results from OpenVAS versus some other things in the open source world.
I was just about to ask, do you have the results done for, like, what's the comparison of OpenVAS, say, to something like Tenable or one of the other paid subscriptions?
Yet. Adrian's working on that now, so he has all of my data from the open source stuff and access to all of my air quotes research. Right, it's really just my test runs of everything. And so right now we're actually working on running the commercial scanners and pointing out any differences. I do have to say, having run the commercial scanners before and all the open source scanners, I'm pretty impressed with some of the stuff in OpenVAS. In the webcast, I'll show you how to recast vulnerability severity in OpenVAS, which I was like, this is a free and open source project, and it has them. Like, that's actually really cool. And also some of the, like, it'll find OpenVAS. What I liked was it'll find default credentials. If you're like me and you forgot to remove the Pi user and reset the default Pi password, and you've enabled SSH, OpenVAS actually finds that and says, hey, dummy, you forgot to change the default password on your Raspberry Pi. I'm like, oh, duly noted. That was good. I like that finding.
Hey, Paul, here's your PCI pop quiz for the week.
Yes.
When did PCI first introduce the concept of what today we would call vulnerability prioritization, but the ability to recast the severity of vulnerabilities?
Oh.
Take a guess.
2009.
Oh, you're
very close.
Looking for a year or looking for a PCI version?
Either one.
Okay.
And Paul's definitely in the ballpark. There was no release in 2009, but version 2 of PCI Data Security Standard, which was released in October 2010.
There you go. Because the reason I was able to guess that was because it was around the time I started at Tenable.
Gotcha. Very good. you pass.
Without getting into how your bake-off between them went, how's the maturity of the UI once you've got it up and running versus some of the other ones you've played with?
Yeah, the UI, and nothing against Greenbone, right? But the UI is a little rough. But I mean, it's free and open source, so
it matches the install process.
Yeah, it's a little, it's a little rough. A little time with it, and you get by. Compared to some of the, I think a lot of this is just funding and maturity. The other people have the nice React interface with all the fancy bells and whistles.
Uh-huh.
I don't know effectiveness-wise if that really makes a bit of difference. I mean, I'm able to run scans with OpenVAS, take advantage of the results. It finds stuff that I was like, oh, I need to go fix that. So it's good enough, Lee. And I think there are certainly more advanced features in, like I've got consoles on Rapid 7, SecureWorks, and Digital Defense, and all their interfaces look fairly similar. Like you can tell they're on some modern JavaScript framework and have done a nice job with the UI. They all don't look that all that dissimilar from each other. So yeah, OpenVAS gets the job done.
Cool.
Sweet. That concludes this technical segment. Stay tuned in the next few weeks or so. We'll be doing Nmap and coming up soon a webcast. So stay tuned. Coming up next, Patrick Waldrell from Objective-C. Stick around.